Good morning guys and welcome to my channel Mind Your Math and to a very interesting chapter which is trigonometry. Trigonometry is one of the most important chapters of grade 10 and we are only studying the basics of trigonometry in this particular class. We study so much of trigonometry and trigonometry related stuff. Calculus is splashed with trigonometry. There is so much of trigonometry everywhere in higher maths. It is very important that you get your foundations right. Now, personally speaking, I always feel trigonometry is one of the easiest chapters of class 10, though you might have heard otherwise, and there is a way in which you should be studying trigonometry. Now, before I begin the class, I want you to tell you the normal statement that if you are having a doubt, you can drop a comment or mail me at the mail ID given below in the description box. Now, let us start with the introduction to trigonometry. Let us start with the basics. What is trigonometry or what does exactly trigonometry deal with? Trigonometry mainly deals with the sides and the angles of a triangle. Now, when I am talking about the sides and angles of a triangle, it can be any triangle. But for your convenience and because I am teaching trigonometry for grade 10, let us say trigonometry deals with the sides and angles of a right angle triangle. Why did I suddenly change any triangle into a right angle triangle? The reason is because we are doing only the basics or the introduction to trigonometry in this particular year. So, right angle triangle is from where we start our basics. Now, any triangle, before I start with any triangle and the trigonometric definitions related to it, let me ask you something. What is a triangle? Why is triangle so important? Triangle is the first closed figure that can be formed by straight lines. Three straight lines, it forms a triangle. So I can have a triangle like this. I can have an obtuse angle triangle also, an acute angle triangle also, and I can have a right angle triangle. Trigonometry deals with the sides and the angles of a triangle, which means this side, and this side, and the angles over here. Let me mark it as theta, theta 1 and theta 2. Similarly, all the triangles have got three sides and three angles. So, whenever the triangle has got three sides, as long as the triangle has got three sides and angles, we are dealing with trigonometric formulations regarding that triangle. And because we start the idea of trigonometry from right angle triangles, I will be talking only about right angle triangles for the time being. Clear? Let me get you guys used to certain concept regarding the triangle. So keep this very clear in your mind so that when we move on to studying the latter part of the trigonometric ratios and identities, it is very clear inside your mind. You have a triangle out of which one angle is a right angle triangle. As I told you, we are dealing only with right angle triangles in this chapter. So I have a triangle ABC which is right angled at B. How many angles are remaining? Two angles are remaining. One is angle A and the other is angle C. Okay, now if I am naming the angle A as theta, this angle C, let it be theta 1. So this angle is 90 and this angle is theta. What can be angle C in terms of angle A and angle B? The sum of the angles of a triangle is a 180 degree. So can I write theta 1 is equal to 180 minus 90 plus theta, thus giving us 90 minus theta. Okay. Similarly, if I want to write theta in terms of theta 1, can I write theta is equal to 90 minus theta 1? You are clear with this, right? Now, the next concept. This is a 90-degree angle, this is the theta 1 angle and this is the theta angle. Now, theta 1 and theta can have any value ranging from 0 to 90 degree. Already 90 is gone, remaining 90 is there. That can be split in any which way between these two angles, which means that if theta is 30, this has to be 60. If this is 15, theta has to be 75. So any angle, suppose this is 33, the remaining angle will be here. Suppose this is 27, the remaining angle will be here. Clear? Now the next concept. Look at theta. Okay, it is standing at the corner A. Standing at the corner A, when you look at the triangle, what is my opposite side? The side opposite to theta is BC. But the side opposite to theta 1 is AB. Clear? The side opposite to theta is BC. Side opposite to theta 1 is AB. I am going to write down these particulars in a table so you get a very clear understanding of which angle I am talking about at what time. This is your diagram. This is theta and this is theta 1. So, for angle theta and this is for angle theta 1. What is the opposite side? Opposite side for angle theta is BC. What is opposite side for angle theta 1? Standing from here, when you look here, it is AB. What is the adjacent side? What do you mean by adjacent? Next to me. Who is adjacent to me? Who is next to me? So what is the adjacent side to theta? One is our hypotenuse. Don't talk about hypotenuse. You are not talking about hypotenuse. What other than hypotenuse is the adjacent side? For theta, the adjacent side now will be AB. And what about theta 1? For theta 1, the adjacent side will be BC because again we are not considering the hypotenuse. Clear? Now you know how to write down the opposite side and the adjacent side of the angles of a triangle. This is our first sum in this particular chapter. This is just to make you guys understand the concept of adjacent angle, opposite angle, and how to transform an application problem into a normal right angle triangle. Very basic. Let us get started. A boy is standing under a tree 12 meter high. A ball is at a distance of x meters from the point where he stands. A monkey sitting at the top of the tree eyes the ball and the line of view is 13 meter long. Find x. Write the opposite side and the adjacent side with respect to the monkey and the ball. So I hope you have understood the question clearly. Let us draw a rough diagram before we transform it into a proper mathematical diagram so that you will get a clear idea about how to do it. So what do we have? We have a tree, very easy to understand. It is 12 meters high. Okay, a tree, unless specifically mentioned, stands straight. Do not assume any angle to the tree. It is slanting or anything unless anything is mentioned to you. Now a boy is standing here. Height of the boy is not mentioned, which means it is negligible. So we consider boy as a point when we are transforming it into a mathematical diagram. Now there is a ball, it's a ground. There are no bumps, there are nothing. It's a level ground unless something is mentioned. So here there is a ball. So let us make it here. So it is x meters. There is a monkey sitting over here. Again, nothing about the size of the monkey. We assume it's a point unless something is mentioned. This line of view is given to be 30 meters long. Okay. Can you find out any angle in this? This is 90 degree. The angle between the ground and the tree is a 90 degree. Now, let us make it into a mathematical diagram. This is our tree, representing it as a line without all these leaves. This is our ground. Now, let here be the ball. It is assumed to be a point. Point means it's a point on the line. Boy is a point on this line. Monkey is a point at the height. This is 13. This is 12. This is x. Now, can you suddenly find x? This is a right angle triangle. Basic Pythagoras theorem will give us the value of x as 5 meter. 13 square minus 12 square. Now, the second part. We need to write the opposite side and the adjacent side with respect to the monkey and the ball. Monkey and the ball. Now, let us write first the opposite side. Monkey is over here. The opposite side is our ground. So, ground is the opposite side, which is 5 meters. Monkey is here. What is the adjacent side? I told you not to consider hypotenuse when you are considering the adjacent side. So the adjacent side is a tree. It is 12 meters. Where is my ball? What is the opposite side for the ball? It is a tree, which is 12 meters. And what is the adjacent side for the ball? It is a ground, x, which is equal to 5 meters. I now hope you are very clear with the adjacent side and the opposite side, and that the application problems can easily be transformed into right angle triangles. Unless the height of something is mentioned to you, that something has to be considered as a point, which means the boy in this case and the monkey in this case and the ball. They are all points in those straight lines. Clear? So now we have learned to identify right angle triangles by locating its opposite side, locating its 90-degree angle, the hypotenuse and the adjacent side. We learned that opposite side and the adjacent side can interchange when we interchange the angles. Okay, now let us move on to trigonometric ratios before we move on to trigonometric identities. Now, what are trigonometric ratios? Now, you need to understand that they are ratios. You have learned about ratios. What is a ratio? Ratio is basically comparison of two quantities. If I say that the mark of two students are in the ratio 5:2, does that mean that the student A has got 5 mark and the other student has got 2 mark? No, it just means that their marks are in the ratio 5:2. For all you know, their marks could be something like, let us say 100, and the other student's mark could be 40. The ratio between them is 5:2. Even in the case of trigonometric ratios, you need to understand that they are not absolute values. Again, they are just comparisons or they are just ratios. Okay. Now, before we move on to what exactly each of the ratio means, let us first learn the names of the trigonometric ratios. There are 6 ratios. When you start learning, it might seem like, oh my god, this is too much, but trust me, this is going to be so easy that you will just automatically name the ratios and the values and the identities just like that if you keep practicing enough. Okay, first let us start with the names of the ratios. Names of the trigonometric ratios I have written over here. Sine, this is pronounced as sine. SINE is the complete name. For convenience, most of the time we end up writing as SIN, but we still call it as sine. This is cosine, we call it as cos. This is tangent, we call it as tan. Now, I have written it over here because these are inverses of each other. This is cosecant, we call it as cosec, or sometimes in some books you can see it as CSC. This is secant or sec, and cotangent, which is cot. Now, these are the 6 trigonometric ratios. Before I go on to explain what each ratio means as far as a right angle triangle is concerned, let me tell you that you do not write sine. What is the sine? It is not like that. You mention the angle whose trigonometric ratio sine has to be found. So, always the trigonometric ratio is followed by the name of the angle. So, it has to be sine A, cot C, cot A, cosec B, depending upon how you are naming the angles. So, always understand this is wrong. This is correct. Sine of A is not sine into A. It is the trigonometric ratio sine of the angle A. Cosec B is not cosec into B. It is the cosecant value or the trigonometric ratio cosec of the angle B. Okay, that is how you should understand it. It is not multiplication. It is a trigonometric ratio of this particular angle. Okay. Now, let us move on to what each trigonometric ratio means. Sine of any angle is defined as a ratio of the opposite side to that angle which we are taking by the hypotenuse. For ease, we write it down as opposite by hypotenuse. Okay. Now, you know the definition of the sine of any angle. Let us write down the values of sine A and sine C using this definition. So, what is sine A? I am going to use the short form, this. Okay. Opposite side by the hypotenuse. And what is sine B? No, I mean, what is sine C? It is AB by AC. Okay. So, using the definition, we have written down the values of sine A and sine C by naming the sides. We do not know the length of the sides. Now, let us define what we mean by cosine of an angle. The definition of cosine is adjacent side to the angle by the hypotenuse. In short form, we can write this. Once you are familiar, adjacent side by hypotenuse. Sine is the opposite side by hypotenuse. Cosine is the adjacent side by hypotenuse. Now let us write down the value. What is cos A? This is cos A. This is A. What is adjacent side? AB. Hypotenuse is not going to change. What is cos C? This is adjacent side. Okay. I have written down sine of two angles and the cos of the same two angles. What can you observe? You can see that the sine of the first angle is the cos of the second angle. And sine of the second angle is the cos of the first angle. There are only two angles we are bothered about now. So the sine and cosine values actually interchange. The reason being the sides interchange. Opposite side becomes the adjacent side for the other angle. Okay, you are clear with it? Can I move on to the next trigonometric ratio? The next trigonometric ratio is the tangent or the tan. Now, do not get confused between the tangent when you are dealing with circles. There is a different tangent. This is the tan of a function. So, instead of saying tangent, start using tan. So, the definition of tan, see, actually you need to study only these two. The remaining just follows from sine and cos because tan is a ratio between sine and cos. So, I can say that tan of any angle is the sine of any angle by the cos of the angle, which basically means this is a ratio between the opposite side and the adjacent side, because when you take the ratio between sine and cos, the hypotenuse is common, which gets cancelled out. So, what is tan of A? The tan of A is actually opposite side by the adjacent side, which gives us BC by AC. And what is tan of B? Sorry, not AC, my bad, AB. And what is tan of C? Tan of C is equal to opposite side by the adjacent side, which will give me AB by BC, which again you can see are inverses of each other. Clear? So we learned about sine, we learned about cos, we learned about tan, we learned that sine and cos are the things that we really need to understand and by heart. The remaining things can just automatically follow from sine and cos, because the first one, tan, is a ratio between sine and cos, which will give us opposite side by adjacent side. Okay. Now let us do the remaining three ratios, which are actually reciprocals of the ratios we learned right now. The next trigonometric identity is cosecant or cosec. I told you can also write it as CSE. Okay. Cosecant is a reciprocal of sine, so it becomes hypotenuse by opposite side. Sec is a reciprocal of cos, it becomes hypotenuse by adjacent. And cotangent or cot is a reciprocal of tan, it becomes adjacent by opposite. Sorry. Okay. Now, let me ask you one thing. Suppose I have the sine of an angle. I also have the cosecant of an angle. I am multiplying them together. What will I get? This is the reciprocal of this. I will get 1. Similarly, cos of an angle into sec of an angle will give me 1. Tan of an angle into cot of an angle will give me 1. Now, let us use some numerical values over here, give value to the sides and apply these trigonometric ratios and see what we are getting, so that learning only theory will not help you understand the concept. You also need to apply it to the numerical part of it, so that you get a very clear understanding of what you are studying and how to apply. Consider a right angle triangle PQR whose sides measure 3, 4 and 5 as shown in the figure. It is right angled at Q. We have to find the values of the 6 trigonometric ratios and also prove these two statements. Okay. So let us do the first part. It is finding the values of the 6 trigonometric ratios. So let us start with the first one. The first one is sine. So let me draw a table over here. So angle we need to find for angle P and angle R. So this is for angle P and this is for angle R. The first one that we are going to find is sine P. You know the definition of sine. It is opposite side by hypotenuse. So sine P will become 4 by 5. Okay. Now we will first finish with the angles of sine as angles of P. So next is cos P. Now cos P by definition is adjacent side by hypotenuse. So for P, the adjacent side is a 3 and hypotenuse is a 5. So I will get 3 by 5. Now I am not even going to look at the remaining angles or the triangle for finding out my tan, because I know this is sine by cos. So my value is 4 by 3. Okay. Now next one is cosecant. Cosecant P is the inverse or the reciprocal of sine. So I am going to get 5 by 4. Next is sec P, which is the reciprocal of cos. I will get 5 by 3. And cot P, the value is the inverse of tan P, which is 3 by 4. Very easy. Let us do for angle R. What is sine R? Opposite side by hypotenuse, which is 3 by 5. What is cos R? Cos R is adjacent side by hypotenuse, 4 by 5. Or you can just look here and write it ulta, but that is not mathematics. Please understand what you are writing. So check the diagram and write it. Please do not go for easy tricks to remember trigonometry, easy tips to do this particular sum. That is not understanding trigonometry. That is like, getting away with trigonometry. That is not the right way to do it. So please don't resort to all those things. Sine R is opposite side by hypotenuse and cos R is adjacent side by hypotenuse. Now, what is my tan R? It is the ratio between sine and cos. So I can write it as 3 by 4. Okay. Now, cosec P. I need to find cosec R is the reciprocal of sine, which is 5 by 3. Sec R is 5 by 4, reciprocal of cos R, and cot R is 4 by 3. We have found all the 6 trigonometric ratios for both the angles. Now I need to prove 2 more statements which say tan P into cot P should be 1. So what is the value of tan P? It is a 4 by 3. What is the value of cot P? It is a 3 by 4. It is obviously equal to 1. And I need to show sine P is equal to cos R. Sine P we got it as 4 by 5. Cos R we got it as 4 by 5. So they are equal. In a triangle XYZ, angle Y is 90 degree and angle X is 30 degree. The value of sine X is given to us as 1 by 2. If the length of the hypotenuse is 24 centimeter, find the length of the remaining sides. So for starting this sum, we first need to draw a diagram so that we get a clear idea about what they have given in the question. So it is a right angle triangle, very easy to draw. So 90 degree. Now which angle is 90? Y. So I will put here X and I will put here Z. Okay. Now what is given to us? Angle X is a 30 degree. Now automatically we tend to write this as a 60 degree. So let it be there. Okay. Now length of the hypotenuse is 24. What else is given to us? The value of the trigonometric ratio sine of angle X or angle 30 is given to us as sine X is 1 by 2. Fine. Now, what is sine of angle X? It is the opposite side by the hypotenuse. So, sine X is actually, if we are going, okay, let me leave it as Y is itself, by hypotenuse. Now, sine X is given to me 1 by 2. So, I can find the length of YZ as 12. So, this length, we got it as 12 meters. I am assuming this is given, it is centimeters. So, it is 12 centimeters. Okay. I know the hypotenuse, I know the base. Can I find the third side? I can directly use Pythagoras theorem, which is xy is equal to 24 square minus 12 square, which is 576 minus 144, giving us root of 432 centimeters. You can simplify it, bring it down to a lower level and that is the length of xy. This is one of the very simple, I mean, this kind of sums they don't even ask because it is extremely simple. This is given to you because you are just learning the trigonometric ratios, and unless you practice, you will not get a clear understanding of what you are trying to apply over here. So from this particular sum, you know that when any of the trigonometric ratios are given and one side is given to you, you can easily find the other two sides.